Next concept we will see the capillary effect concept. The concept of the capillary effect. Capillary effect, the most used is the whatever we are to ascent of sand. The trees, all branches, all leaves are getting water in the through the xylem. Is the ascent of the sand. Is due to the capillary effect. How it is happening? So to understand this concept, taking one container. This container having some water. Now one very small tube, small diameter tube, one very small diameter tube that should be less than 1 centimeter or 10 mm. Should not be more than this. This tube dia always should be less than 1 centimeter or 10 mm. Then only it will be effective. Then if you see there is a rise of the liquid level. If you can see there is a rise of the liquid level through the tube. This effect is known as the capillary rise. This is the capillary rise. Why it is happening, this capillary rise? Because the adhesive force between this tube is made of glass tube we are taking it as a glass tube, and this is the water. So adhesive force between water and glass tube is much more greater than the cohesive force between water molecules. Then only it will be happening. Then only this kind of the rise you can be able to see. Through the tube, then only you can see the rise of the capillary. And this height, H, is a capillary effect, capillary height, or capillary rise we have done. So if the adhesive force between water and glass tube is more than the cohesive force between the water molecules, so this kind of nature will be takes place. And what would be the surface here? The surface here over the glass tube, if you consider the glass tube, the surface will be not in this way. It is not in this way, the surface. Rather than this, the surface will be looks like this. The surface is looks like in this. If you're magnifying it, it will be looks like in this. And this surface tension will be acting in this direction. Surface tension. And this glass and its angle is known as a contact. This theta is the contact. Contact. In this case, the contact angle is less than 90 degree. This is a less than 90 degree. So we can ensure there must be capillary rise. We can ensure there must be capillary rise. So that is the concept here. So this kind of the capillary rise you can see in the natural cases, the xylem, because xylem diameter is, we'll see the diameter case later. During the calculation, it will be very easier to understand. So another concept, we will see the capillary depression first. Then we'll go for the calculation. Same way, over the container, if you insert a tube that is less than, insert a tube that is less than the same 10 mm diameter. And in the container, there is a marker. Marker is there. You will see the level drops. You will see the level drops to the tube. How much drop? This is known as the capillary depression. Why it is happening? Capillary depression is happening because here the adhesive force between mercury and glass is less than the cohesive force between the mercury molecules. Cohesive force between mercury molecules. So here the cohesive force is more than the adhesive force. That's why this kind of the depression will be happens. This is known as the capillary depression. So either capillary rise or capillary, in case of the capillary rise or capillary depression, it depends on the adhesive force and cohesive force. Whenever adhesive force between the liquid and the solid surface is more than the cohesive force, there must be the rise. If the adhesive force is the less than the cohesive force, there must be the depression. And here, if you again, if you see the tubes, you will see here the surface is like this way. Surface is like this, mercury surface. So surface tension forces is acting in this way. And this angle, this theta, is the contact angle, which is greater than 90 degree. So theta greater than 90 degree will also gives you or implies you that it is a definitely capillary depression. If theta is less than 90 degree, capillary rise definitely it will indicates. If theta is greater than 90 degree, it will indicate there is some capillary depression. So some theta values for pure water, if you are considering the pure water and glass, in that case the contact angle is 0 degree, perfect. In case of the normal water, whatever we are getting it, normal water and glass surface, theta is nearly 28 to 29. In case of the mercury and glass surface, this theta value is nearly 130 degree to 135 degree. So hence you can see for water and glass there must be a capillary rise, mercury and glass surface there must be a capillary depression. Now we have to finding out what is the capillary height or capillary depression, how much. some qualitative we have seen now. Now we'll go for the quantitative analysis. In case of the quantitative analysis, whenever we are doing, we have to draw this. That you consider. So we are talking about the capillary effect. Now we'll see. We have seen that if adhesive force between the liquid molecules and the solid surface, if it is more than the cohesive force of the liquid molecules, then there must be the capillary rise. Hence, in that case, the contact angle should be less than 90 degrees. And if the cohesive force of the molecules, liquid molecules, is greater than the adhesive force between the liquid and solid surface molecules, then in such a cases, there must be the capillary depression. And in case of the capillary depression, the contact angle should be greater than 90 degrees. So that is the qualitative analysis. We have done it. Now we thinking about what is the formula regarding this capillary height or capillary depression. After getting the formula for it, we'll see some numerical problems and we'll call it a day in this portion. For the qualitative analysis, we have done it. Now, quantitative case. In such a case, we will take one container. In the container, you insert a tube. You insert a tube. So, let you take here the capillary rise is happening. There is some capillary rise. And the height of the rise is h. We have to find it out, the relation here. What is the values of h? So here, how much rise is there? And in this case, so what the equation you are getting it, just to remember that just few hours back, previous lecture you have seen. Delta P is sigma into 1 plus R1 plus 1 plus the equilibrium equation you are getting. So hence here, if I magnify this portion, the tube, by magnification, I have made it here like this. This surface is like this. Okay. So here, surface tension force is acting in this way. There's a sigma. Inside there is liquid. Outside, atmospheric pressure. Inside there is a pressure Pi. Now, which is more, Pa or Pi? In this case, again the concept, it is your interface. This is your interface. Here, the concave portion in this portion, that is the concave portion, Pa pressure. And convex portion pressure is Pi. So definitely Pa is greater than Pi. Definitely Pa is greater than Pi. So I hope you understand why it is happening. As here is the lower pressure, Pi is the lower than the Pa. As here is the lower pressure, that's why water is going on. That is another concept. Okay, we take it in this way. This portion, Pi and Pa, where So your surface is like this. The tube radius, the radius of the tube of tube, capillary tube. Better to say it is a capillary tube. Is R. R is the radius. And this portion radius of the curvature is smaller. This portion radius of the curvature and this portion radius of the curvature is a smaller. So it is a smaller, hence you see this thing. This is a capital R. This angle is theta, which is nothing but the contact angle. Theta is the contact angle. So as this angle is a theta, so this is also the theta. As this angle is a theta, so perpendicular of this line is this one. This curvature line is the perpendicular to the surface tension. And similar way, the horizontal perpendicular. So as it is the theta, so we can write it down. This is also theta. So cos theta will gives you capital R by small r. So small r will gives you R by cos theta. Small r will gives you R by cos theta. Here, in this equation, R1, R2 is equal to R. Because the surface is like this way. So all portion having the equal curvature. Surface is like this way. So all portion having the equal curvature. That is equal to R. So delta P, you can write it delta P is equal to sigma 1 by, so 2 by R. 2 by R means 2 cos theta better to write it 4 sigma cos theta by diameter of the capillary tube. So D is the diameter of the dia of the capillary tube. So delta P, the pressure difference, is equal to this one. What does it mean by the pressure difference? H rho G. This pressure difference is causing the height. This pressure difference is causing the height. The fluid statics, you will see this concept, you will get this concept. The fluid mechanics, when you will see, you will get the concept. Here, lower pressure, that's why fluid is coming inside. And there is a rise. So what is the pressure difference? This pressure difference is causing this height, capillary height. Needless to say, it is H, rho of the liquid, density of the liquid into gravitation, H rho G. So H should be equal to the 4 sigma cos theta by D rho G. This is the most important equation. H is the capillary height. If theta is less than 90, so H will be positive. That means capillary rise. If the sigma is greater than 90 degree, H would be negative. So it is a capillary depression. So from the quantitatively, you can also define this thing. So from your equilibrium concept, you are getting this thing. This can be proved in other ways. The same thing, you can prove it in a different ways. And what is the way? That is also very simple way. How to getting this thing. So this is one kind of the proof of this portion. There is another proof, and it is also, that is the one line proof. So how it is? You take one container, same way. The same way from the force balance you will do it. Obviously also the force balance, the equation comes. Here also the force balance. Where the surface is like this. So here surface tension force is acting, and this tube capillary tube dia is B. So it is surface tension is acting over the periphery circumference. So over the circumference. So what is the force due to cause of the surface tension? So force due to cause of surface tension. Force due to cause of the surface tension, sigma into the circumference. That is the force. So sigma into pi is acting in this. This angle is the contact angle. And this contact angle, if you take the, there is a cos component of the force. Ready? This is a sine component. Sine component is balanced by 1. If you see, in that side, sine component will come in this side. In that side, it is opposite. So sine component will be self-balanced. But there must be some cos component. So force due to the surface tension of the cos component will comes in. That is acting in upward direction. The cos component of the force in upward direction. So this force is balanced with the weight of the water column. Water column or liquid column. Or liquid column. Weight means this weight. This liquid. This extra liquid height, this weight of the liquid is balanced by this force. So this surface tension force is holding this liquid. It seems like that. So what is the weight of it? Weight is the mass into G. What is the mass of this liquid? Density into volume. What is the volume of it? This liquid column. Pi by 4 square. Area, cross-section area into height. These two forces are balanced. So surface tension force is holding the extra amount of the liquid. So we can write it down here. It's equal to rho sigma by 4 square. I will be cancelled. And B will be cancelled. And H will comes 4 sigma cos theta. And D goes. Same equation will be arrived in this manner also. So one you can get it due to the pressure difference, one due to the surface tension is holding the weight. The two way you can derive this portion. Ultimately the result will come in the same manner. So capillary here also the theta value, if it is less than 90, so H will be the positive values. Capillary rise, if theta values greater than 90, H will be negative. Capillary depression. For the mercury, that's why theta value is nearly contact angle 130 degree. That's all here problem. Now we'll come to some numerical problems here.